Okay, so let's see. Let me pull up my existing code. There we go. I think I've set this. That's not, shouldn't be evaluatable. Okay. All right. Now, let's just see Max's claim. TS mod. So this is mine. What is mod evolve? That's my modern evolution thing, right? And this is post tag system final state, 1,000 steps. Okay, hunkadory. Why is he? Oh, I see. That's this thing here. So if I were to put a 1 there, I get a completely different result. So I don't understand this. These things are not
Same inputs give the same results, then they should be good.
Yeah, but I understand, but I don't understand why this is the same input. How do I know that that 1 there? Do you understand what I'm saying?
Oh,
Why is that one?
the what's in the brackets is kind of what's ignored, I think.
But it's not ignored. Look, I changed it and I get a different answer.
Ah, I see.
See what I'm saying?
Mm-hmm.
Oh, God. This is what needs to be like straightened out as opposed to not straightened out. Okay, so I don't understand this already, right? So TS mod evolve. I don't understand. How do I get? Okay, so hold on. Let me do something here. So if I go, how do I go from the ordinary thing to this to mod form, right? So let's say I say this thing here. Do you understand what I'm doing here? So I say, and there's a residue of 0 there, and I say to mod form of this.
Right.
How could that be the right result? Oh, because it's something. Okay, so what I want to do here is to say from mod form of this guy here. What's this? S, res pad. Okay, how do I convert from this form? Remember what I was doing last time, right?
Right.
So can you remind me how this was working?
We were putting in spaces, brackets.
No, wait a minute.
The
Blocks plus residue, okay?
right.
Okay, so this is blocks plus residue. And this is to mod form, but where's from mod form? Do you understand my question? Oh, maybe I see. I need to put a padding parameter in here.
Yes.
Okay, fine. Okay, now but I don't understand because this output is more specific. It's going to matter. Okay. Do you see what I'm saying? It's going to matter what those intermediate things were, isn't it?
I think so. I always just check these things. I've got dyslexia, so I'm wrong almost all the time when it comes to these sorts of parity things. That's why I always just run code and check.
Yeah, I understand. But can you resolve this with Max? Okay. So what I'm trying to do is make sure that I can get something where I start from forget all these compressed forms. You understand what I'm saying?
Right. The one thing you can see in the from mod form is that that zero at the end is something that's important. And
Yes, I get it. 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 But I want to know if I run for 1,000,000 steps, right? I want to know how do I reconstruct? So in this case here, if I just say, wherever it is, if I just say, you know, let's see.
but that's why changing 0 to 1 had an effect on TS mod evolve.
Okay, TS direct evolve list. Okay, so if I go here, this is this thing. Okay, so I say TS direct. I do not like wasting this time right now. It's just really annoying. Okay, and let's say I go for 1,000 steps there.
Mm-hmm.
Oops, I just want to do the evolve. Okay, there it is. Okay, so now I say to mod form of that. Okay, great. I get this. Okay, so now what I want to do is I want to go backwards from here to get this. Do you understand what I'm saying?
Right.
Okay, but if I go from mod form, okay, I get that.
Right.
Do you understand what I'm saying? So I want to know, how do I get the correct version of this? Do you see what I'm saying?
Right. It's usually lossless, but in this case, since we know it's been run, there probably is a way that can be deduced what it was.
No, it's not lossless. It's lossy, right? It's
Yes.
losing information here, right?
Uh-huh.
So the question is, how do we figure out? Okay, so if I go here and I say TS direct evolve a percent comma 50, 30, let's say. Okay, I get a definite thing.
Mm-hmm.
Right? So now I can do the same thing, and then I can say to mod form of this. So in other words, I can determine what I'm going to get by explicitly running a few steps and just cleaning out. But I'm a little bit confused because these are things which can be right. What is the significance of these? These are things where they will not matter. Is that a true statement? They will not matter. Yes, they don't. They obviously don't matter here, right?
Right. Mm-hmm.
But so whatever I put in here, I can't get it wrong.
Correct.
Okay.
If you used say ones for padding, it would be the same.
Right. But what the residue is also doesn't matter, right?
The residue can matter, actually.
But it can't, because look at Max's representation.
It
Do you understand? Max's representation does not contain a specification of the residue. It only says its length.
correct.
Okay? So here, if I were to do this, okay, and I were to say 1, 1 up here, I put this in here. It's giving a different answer. So I don't get how Max's representation makes any sense. Do you understand what I'm saying? I think it's nonsense. Right? You see what I'm saying?
I get what you're saying, but I'm a person who has a hard time with just left and right, and this is like mind factoring to me. This is something I actually need to run the code because I know that I'll just guess it
Go
wrong.
ahead and run it. Go ahead and run it. I mean, okay, look. I don't understand why it works this way. I don't understand why it only cares about the phase. And in fact, I'm getting evidence here that it doesn't only care about the phase. Right? Okay, so here, now the only thing is if I say to mod form of this, okay, I get that. Okay, so now let's say I do to mod form of this. I get that. Okay?
Mm-hmm.
So they've got the same mod form in terms of Max's code, right?
Right.
Okay, so
And
now
you could also do just 1 0 and 1 1, and it should just be 0 and 1. And if you another one would be to have nothing
it
at
doesn't
the
matter.
end.
Doesn't matter. Doesn't matter. That's two elements here, right?
Mm-hmm.
Okay, so now if I go from this TS mod evolve, okay, from that, comma 50, let's say. Okay, now I go TS mod evolve that, comma 0, 0.
Shouldn't make a difference.
But it does. So what's going on here?
Oh wait, no, it does make a difference because these are the it's if you used 1 0 though, with that second one, it should be the same.
No. Max's code only gives the number.
Right. I'm saying if you did 1 0 instead of 0 0 for that second one, it would be the same as the 1 1.
Doesn't matter. Okay, that's fine, but I don't care. Max's code is only specifying the phase, right? That's not enough information. Do you understand what I'm saying?
No, it is.
But it isn't. Look at it. It's not enough information. See, they're different results.
It depends on the phase, I believe.
Look at the phase. This is the only specification of the phase. In my way of setting it up, the phase is specified by the length of the residue. You see what I'm saying? Max's code only relies on this. Okay?
Right. And Max's new code is trying to do it completely your way, I believe.
This is Max's new code.
Oh, okay. All right.
Okay, different results. They're just different results.
Right. I'm pretty sure that if there's one item in the residue, the first item in that residue will make a difference.
I don't care. This is okay. So then what does Max's thing mean?
With the phase?
Yes, that's what I'm asking, right? This is what we have with the residue, okay? This appears to be incorrect. Right, that claim there. Am I making sense?
Mm-hmm.
Okay, so how does Max's code represent something with just a residue like that? Just a phase number like that? Do you understand my question?
Right. I believe he's going one forward. It's the last digit that's different between your version and his version.
What are you talking about?
The
Oh,
last
no. His code was supposed to do exactly what my code does. Does it or does it not?
which came first?
Look, this is my code.
Right.
Okay. This is his code. In
The-
this particular case, it seems to give the same answer.
right.
Okay. So I'm asking in general, what does it do? Right. And what I'm saying is his code contains only the information about the phase. My code contains the content of the residue.
Oh, well,
What
we
I'm
should
saying?
do a few other examples and basically show that his code doesn't work, and that will
I
be
know it
very
doesn't
helpful.
work. I just gave an example here.
Oh,
It
okay.
doesn't work.
Right. But we should basically
I'm
give
not
that,
going to debug his code for him.
but we should
That's
give
up.
him the example to work with.
I gave him this example. I just sent it.
Oh, okay.
That's really annoying. This is what I hoped you would resolve today. God. Okay, let me look at something else. I don't know what this is. This is something else Max sent me randomly. I don't know what the hell this is. Do you have any idea what this is?
Not really, no.
What the hell is he doing here? I He's got to rip that shit out. Rip that shit out. Don't ever want to see that again. What is he doing here? No. This is extremely annoying. This is just a pile of unusable stuff. Unusable and incomprehensible. So I'm going to have to do it myself again. It's kind of annoying. Let's see if that works. Pretty much guarantee it doesn't. Why is that in some stupid initialization cell? What the heck? What is this? Oh, gosh. How can this be vertex labels to automatic? This isn't right. I mean, this is showing that's this transformation, right?
Mm-hmm.
But so what should be the case is that if I say TS direct evolve list of, let's see, I want to get the thing that goes for 409 steps. Where's the thing that goes for 409 steps? Do you know where we had that?
No, I don't know.
Our first long case is here. Okay. TS direct evolve list. Let's say 410 steps. 450 steps. I don't know. Okay, so then I say, oh, I've got to convert it to Max's form. He was supposed to make it work with my structure, right? But he didn't do that, did he? Is that correct?
I don't know if he got a full spec for what he needed to
Oh, no,
do.
no, he did. We gave it to
Okay.
him. It's the residue at the end, right? Can you make sure he does that? Right? And clarifies what's happening with these residues, right?
Right.
You understand what I'm saying?
Yes, I'll need to write this down though.
Okay, so write it down, please. That's kind of interesting. That's the causal graph.
Right.
So we should be able to label this. So in other words, those things should be labeled with, let's say 110 we'll label with okay, so if I do TS direct evolve list here, and I say which ones of those were, well, I don't know which event. I mean, I guess these are numbered events, right? So if I say GGG equals this, and then I say vertex list of GGG, right? Then I say, so the first one, so to figure out whether it is, it's the case, right, that if I just look at the outputs from this, right, that the first element will determine in each case whether it is a 0 or 1, right? Do you understand what I'm saying?
Yes.
what the heck? What the heck is that? Okay, there we go, there. Oh. Okay, what does he have it called now? Oh, for goodness sake. Come on. What is this? Whatever. Okay, so here I probably want to say okay, that's kind of interesting actually.
Yes, looks nice.
Corn plant. I don't know quite what we learned from these causal connections. I mean, we might what happens when we wind up in a cycle, I wonder.
We can try that with either your code or my code, which is pretty much equivalent, but maybe more direct.
Okay.
I posted it in chat.
Okay, so what is this now? What is this?
Those post cycles, those are all of the cycle generators
Okay,
for a
so
given
where are the
length.
cycles?
What's that?
Where are the cycles?
Oh, just do say post cycles 5, and that'll give all the post cycles of length 10. the compressed forms.
Where are their residues?
These are ones where it would be residue empty brackets.
Okay.
And for distinct cycles.
Oh, no, wait. These are compressed forms, right? This is a cycle.
Yes. But
Okay.
sometimes they're part of the same cycle.
I don't care. That's its causal graph?
For that one, yes. That's the first one. It's
So what do? I pick a random one of these?
yeah, the first one and last ones will be boring.
I think that's what these cycles are always going to do.
Probably.
Yeah. Should I try another case? Can I try 6?
No, sure. More
Yes,
divisors. 12 has
I
more
see.
divisors.
So in other words, there are fewer. Right. So if I were to do the same thing and map it over, let's say, just tuples, 1, 0, like 4 or something. Oh, wow. It's already something really kind of complicated there.
Mm-hmm.
Huh. Let me just record that in my collection here. Oh, actually, there we go. Yeah, there was already a complicated one there. We already knew there was a complicated one there. Let's just do it over 3.
For Max's benefit, it might be useful for you to tell him that you did find this useful.
Even though I'm incredibly pissed off that it didn't.
True, but showing that you're happy will encourage him.
You know, you guys with your study of human condition, I mean, I don't think you're a tremendous expert on the
No, I'm not.
not your skill. The
Hello.
And in chat, I posted code for the counts
of what?
of distinct cycles.
Okay, well, hold on a second. This is your code for. Okay, this is generating. What's wrong with my version of this?
Your version is identical, but it's recursive, whereas this one is direct.
Okay.
You can just use integer partitions as the driver,
Okay.
but otherwise they're identical.
That's the number of distinct cycles.
Right.
Okay.
And you can go to 100 or whatever you want to easily.
Yeah, sure, I understand. And isn't this Fibonacci's? No, this isn't
No.
Fibonacci's.
No, this is basically turns into the bracelet problem.
Oh, okay. I've seen that before. So this is essentially, okay. So
From the tone of your voice, I can hear that you completely understand it.
why are you saying that?
I can just tell that you've got it.
Okay, that's good. Where is it? Here we go. This is the thing, right? It's this thing.
Yes, I think so. And Jessica joined us.
I know. Right, so I just want to look up what I said here. Cyclic addition. It's this here, right? Is that it?
That's almost identical to what we saw in the cycle pictures earlier. In fact, if you look at that picture there in the book and the picture you've got right at the top of your notebook there, they're very similar.
That's essentially identical. Okay.
Oh, and that's the same code, actually. That's
yes, except you've used divisor sum, which is a more modern function which didn't exist before.
I see.
And you've used Lucas L, whereas this doesn't. This uses Euler phi divided by. This has k to the n, whereas you have Lucas L. So I don't understand that quite. Do you understand that?
No, but I'm guessing they'll be very similar.
With some you've got Fibonacci numbers, right?
Yes, the equivalent to Fibonacci numbers, yes.
Right. So this is the pure power. This is the power version.
Ah.
We need the Fibonacci version.
Mm-hmm.
That's what I'm saying.
Yes.
So this is the one for a regular bracelet. This is the one for some bracelet which is, recursing by 2.
Right.
Okay. All right. Okay. Good day, Jessica. Look, okay. The thing I need to do with you is that post archive thing. I've got 2 things. First of all, the Combinator Prize thing. I started writing stuff, but I got stuck because Mano didn't give me the things I needed. Do you know what I need there?
I got.
Okay, then
I can talk with Mano.
Yes, please. Can you make sure that I get that stuff for sure tomorrow, if not before? If Mano is around now, you might ask her if she can join us for a minute, and we can clarify that quickly. And Jeremy started making the website for the S Combinator Prize. We could look at that. And then I really need to write. So you had sent me back this thing from the post archive, right?
Correct.
Okay, so do you understand? So what I need to find here, I have this physical book in front of me here, which has the which is post collected works. And if necessary, I can just photograph a page here, but let me pull it open for a second. Okay, section 35.
I'm imagining a camera on something like a desk lamp with a book under it.
Well, I do have a camera that is a desk, a down-facing camera like that, but I can, yeah, here, let me just use that right now. Thank you for making that suggestion. Okay, let me just move my other books out of the way here, so that it focuses properly. And up, here we go. Let me try to make sure those things don't fall on the floor. Okay. Actually, this is something where you could actually just screen capture some things, Jessica. Hold on 1 second. I think it's this one. Yes, it is.
Well, that looks cool.
I don't know how cool it is, but okay. Okay, so in fact, this particular thing here, you see this? Huh.
Yeah, I can see that really well.
Yeah, okay, but Jessica, can you see this? Because this is what we're going for with the archivists. Okay, do you understand what I'm saying?
Yeah, I mean, I'm reading it. Okay, yeah.
Okay, so what happened is, okay, Post said in 1921 he developed a bunch of ideas. Okay, he then got put off these ideas primarily because he couldn't solve this problem that we're now dealing with. Okay.
Okay.
He then went off and didn't pursue what ended up being Gödel's theorem.
Okay.
Okay. As he later said to Gödel, he would have proved Gödel's theorem in 1921 had he been Gödel. Okay, hold on. Let me just. I'm putting this in history notes 02. Okay, so let me just find the place where he talks about this. Oops. Oh,
I do
look at that.
see girdle representation on the other page.
Okay, hold on. The C.I. Lewis Survey of Symbolic Logic. That's something we're going to need to get a copy of. Okay, Jessica, shall I?
C.I. Lewis, what of?
Here we go. I'll find it.
Okay.
Can you read it or can you not read the screen?
It's a little blurry for.
Um, wait a minute. Do we have? Oh, here we go. Great. Okay, this is interesting. All right, can I download the PDF? That would be nice. Oh dear. Probably other copies of this around. I wonder why it has to do this.
So did we want the post archive to look for anything else, or should I ask them to look for anything else?
Absolutely, they haven't found anything that we need yet.
Right. Okay. Well, what?
I'm working on that. Right. Unfortunately, this thing needs to build a PDF for me. Apparently.
Okay.
Okay. Okay. So look at this. This diary under time accounts. Right. This diary. It says.
Hello.
Hi there. We're sort of in the middle of one other thing here. Hold on. Do you see this? This diary under titled Time Accounts was begun in spring of 1916 and continued until the spring of 1922. So that will contain all of our subject times. Do you see what I'm
Okay.
saying?
Yeah.
And I recommend, I mean, I'm going to send mail to the grandchildren. Okay.
Sure.
But what I want to find is what he says about this actual problem, which I think he talks about here, but I'm not sure he talks about anywhere else. I'm very confused by this. I mean, okay, so here we go. This is the problem of tag. Okay, so this is what he says here. An early unpublished method of the writer completely solved the problem of determining what substitutions would make those okay. Okay, hold on. I'm just going to sort of load this up. I just got this PDF. I hope. Oh my God, it's unbelievably slow. Where is this coming from? This is really weird. Maybe Brewster has a copy of this on the Internet Archive. It's really weird. Ah, there we go.
I was wondering why the name C.I. Lewis was familiar.
What's the answer?
C.S. Lewis
But
wrote a whole bunch of fantasy books. Friend of Tolkien.
I know. He's a famous guy.
Yep.
Isn't he the Lion, the
Yes.
Witch Wardrobe guy?
Mm-hmm. But this was C.I. Lewis.
I am aware. It's a different person. Okay, so this is this. You know, there was a big explosion of interest in all this logic stuff for about 100 years ago. We are about to, I hope, solve a bunch of these problems that it's kind of crazy that it's taken 100 years. But anyway, whatever. I don't know where this section is going to be, and I don't know why this PDF is loading like a snail. It's really odd. I don't understand what this is doing. whatever. Hold on. Let me kill that.
Actually, now that you mention it, Zermelo Fraenkel is 100 years old this year.
Don't get me started on another project. Okay, more like it. Okay, so this is a bunch of logic, and the claim is that this contains the information that this stuff can be converted to strings, which is hardly surprising. Oh boy. Okay, I have to find that. My gosh. It's not like these people, you know. Yeah. All right. Okay. So we'll deal with that. Okay. So here, take a look at what he's saying. Okay. So this is the problem of tag. This is the thing we're talking about, right? And then okay, our friendly problem is right here. Okay, in this amended, do you see what he's saying? Can you see this, Jessica?
Yeah, I'm reading it.
Oops, sorry.
So are we solving one of the absolutely unsolvable problems?
No. Okay, wait a minute. This amended in the first form of the problem. When did he get the first form of the problem? Was it before 1921? Amended form of the problem, I see, was made the major project of the writer's tenure of a Proctor Fellowship in Mathematics at Princeton during the academic year 1920-1921. Okay, so he solved the problem in which mu and nu, what are mu and nu? Mu and nu, mu, I see, so that's just 0, 1, goes to two elements, right? See what I'm saying?
Mm-hmm.
Right? So, okay, so this is the critical sentence there, which I can't, right? Indeed, was the major project of the writer's tenure of a Proctor Fellowship in Mathematics at Princeton, right? That's the thing we're looking for. Does this make sense, Jessica?
Yeah, that makes sense.
Right. So the question is, where are his notes? Okay, so let's look one more page here. Okay, so this is where he says he couldn't do it. Okay. This is his big statement. Okay, he says, while considerable effort was expended, little real progress resulted. Such a simple basis as this, proving intractable.
Perfect.
Okay, when this possibility, wait a minute, seem to offer u greater than 2. Oh, wow, I looked at that case in NKS. It's amusing. Yes, he's right. It's a big mess as well. Dissolved in the particularities of this more primitive form of mathematics, the solution of the general problem of tag appeared hopeless, and with it our entire program of the solution of finiteness problems. Okay, so there you have it. So that's what we're looking for, Jessica.
Okay, great.
Let me just screen cap that a little bit more carefully. Oh, I don't know how to do this. Let me see. Sorry. Just the practicality of trying to keep that. I want to, because I want to send the grandchildren this item. Okay. All right, so there we have that, right? So that's what we're looking for, and you can quote these items to the archivist, right? Just tell them, but
Yep.
you can. I mean, I think I can probably. I wonder whether this book. I mean, probably this article it posts is certainly in JSTOR. Making sense.
Yep.
I don't know whether I can pick it up from this. Yeah. Okay.
Again, we also have mono here.
Yeah, I know. Okay, should we can deal with Mano, then we'll deal with Jessica, then we'll deal with Ed. Okay, Mano, I am struggling. I mean, this is the cost of the fact that we didn't get the combinator thing straightened out. I am struggling with writing some stuff about the S combinator. Okay. I just need to make a traditional form version of this. How do I do that?
Well,
I mean, this is
I've
the big
gotten.
mess that I've got right now. So go ahead.
I figured out what was wrong with combinator plot, so I can submit it. I was just planning on improving
Okay, but
the
I need this kind
documentation.
of now. So what do I do right now?
So you want to display the evolution like this, but with
No,
all
I
of the
want to display
expressions?
it with in traditional form and without this kind of crazy thing here. Okay. How do I do that? Can I use the stuff that's in the function repository or not?
Not at the moment, no.
Okay. Can you send me an update? Okay, so this is what I need to do. This is the point. I'm stuck right now.
Yeah, I can send you a version that works, but also if you just, yeah, I'll get you something. Just
Well, wait a
give me a sec.
minute, wait. So, okay, fine. Okay. Yeah, I mean, in this stuff, I really, really, really don't want things with these kind of naked functions like this. You see what I'm saying? This was supposed to be function repository stuff, and I don't know. Maybe
This is function repository. This should be fine.
okay. So but I don't know what it is because the actual blog doesn't have that stuff in it right now. Do you see what I'm saying?
Yeah.
I mean, there are versions Sushma and I work together to,
Okay.
you know, replace the code, but
It hasn't been done yet. Okay, so Jessica, you're aware of that, right?
Yeah, I mean, you know, I've been working on it, but obviously the other things have become priority.
Okay, all right, okay. Well, I mean, I know you're working on other things last week, so let me show you something else here that we're trying to deal with. So this is a beginning mock-up from Jeremy. This stuff.
Looks nice. I like the colors.
Yeah, I don't think this one's going to work. I think the first one's better. Okay, so this is the bottom part, which this is what we need, by the way. We need the meeting with Xerxes and so on as soon as possible to figure out who we're roping in for this thing. It's a bit static looking, that picture there. I need to, in fact, if somebody can ask for tomorrow, I'll need, let me just see my calendar here. Oh, we've got a live stream tomorrow, which we could work on some of this stuff. I wonder what I should be doing there, if anything. Okay. I mean, I really want to get this done. We really need to get this finished because this is the last thing we need for the Combinator book, among other things, right?
Yep.
That's what, apart from the index.
Right. Jettisoning the annotated bibliography.
No, I've got no help, zero help on that, so I'm not going to do it.
Good.
I mean, I don't know. Where am I going to get it done? Am I going to spend my time on it? No, I don't think so.
Right.
You know, we had asked people for help. Nobody's helped, so whatever. Unless you know of any help that was forthcoming. I mean, we did reach out to some people, didn't we?
Yeah. Sylvia.
All right, and we're back with the eels. Okay. So, do you believe, have you proved that these are all the cycles?
No, but my intuition says that they are, but I still need to prove that with code I'm developing.
With code, or are you just going to prove it as a piece of math?
With code.
How?
Brute force.
How can you do it brute force? How do you not know? How do you guarantee there's nothing longer?
Well, I can't, but I can get a better intuition. But basically, everything up to say 2 to the 20, whether it has a self-repeat at some point.
Okay. So my guess is there's a finite state machine argument that you can make.
Right.
That basically what happens is, okay, let's try and make the argument for a second, okay? Okay, so proof of repetitions. Okay, so assume it repeats. then it has to be the case that a string S. So okay, let's just look at what has to happen, right? So the string S at the beginning has to remove a certain number of elements, and then it has to be a string S with a certain block B at the end, right?
Right.
Has to turn into, after some number of steps, has to turn into, let's see, how does it work? It has to be, see, I think
Well,
there's a way to show that it has to be a finite state machine of some kind.
Well, actually, let's take a certain example. Our length 10 cycles.
Okay.
They're not always length 10.
Oh, I understand.
When
I
we run
understand.
them.
Right,
So
but
how do we classify it when the length is odd and it is part of a cycle, but it's basically has a different phase?
okay, but look. Think about the front of the thing, okay? Basically, the front has to generate. See, think about what we're doing, that trick that Max is using, the trick I suggested about do it 8 at a time, right? So why don't we imagine making that matrix of what we get? So in other words, let's imagine we make the transition matrix from inits from the front of the init to the back of the object, right? And so okay, here's an interesting question. Okay, so let's say, can I get the non-compressed version of these? Do you understand what I'm saying?
Oh yeah, just basically do the 0 goes to 0, 0 and 1 goes to 1, 1, 0, 1, and you get the uncompressed version.
Okay, so here's an uncompressed version, right?
Right. If you add 0, 1 to the end of that, you'll have one of the cycles.
Well, why do I need to add 0, 1?
Oh, that's right. That is a cycle itself, yes.
Okay, it's a cycle of length 4. Okay. Now, this cycle, if I say to mod form, okay, that's what those cycles are, right?
Right.
Okay. Okay. So we make a table of what this actually produces on the back.
Okay.
You see what I'm saying?
Mm-hmm.
So you can tell that this thing here is going to produce 0 goes to 0, 0.
Mm-hmm.
Okay, so that's what that's going to produce.
And there will be an extra 0 at the end.
Well, fine, but I'm just saying, why is there just one extra 0? No, there's an extra 0 at the beginning.
Oh, okay.
Right? Because that's a residue of this. This has all been eaten. Do you understand what I'm saying?
Right. Mm-hmm.
Might be easier to do the 1, 1, 0, 0 there. Because that has no residue.
Right.
There's that thing. And so the claim is that after 4 steps, that has to repeat.
Yes.
Okay, but let's understand why. Because this thing, what we're going to do is we're going to take all... I'm going to leave this to you to prove. I think this is provable. I think it's going to be possible to show that the thing always has to be a finite state machine, that the set of configurations, okay, that the set of configurations that can be on cycles must be a finite state machine of a certain size. And then we can then show that that finite state machine allows only a certain finite set of words. That's what I
Okay.
think is going to happen.
But as a caveat, I've never worked with finite state machines. But they couldn't be too difficult.
Oh, for goodness sake. Try and get Max to help you, okay?
Okay.
And I'll point you to the relevant page in NKS that talks about this stuff.
Oh, I'll read that section. It's easy to, I can find it.
No,
I've read through it.
But which section? I don't think you can. I don't think you can. I don't think you'll find it. Just a minute.
Oh, okay.
This is part of the story here. Okay, for a cellular automaton, you can show that certain blocks are excluded. And maybe you can show that here too. In fact, here's a question. Do we know in a big, long thing like this? Okay, so one of the things that I wanted to do was to do, okay, so this is the sequence, right? That you get. This is the complete sequence there.
Okay. Uh-huh.
Okay, so now the question is, if I were going to look at this as a random walk, for example, if I say list step plot -1 to the this, accumulate that. Okay, that's an inverted version of the growth.
Mm-hmm.
Okay. Okay, so now the question is, what happens if I say, if I put these in pairs? Well, actually, so if I take okay, if I say partition that, comma 2, comma 1. Okay, so the question is there any difference? Are we starting to see any differences between, do you get what I'm saying?
Right. We could change this to a 2D random walk.
This one here.
Mm-hmm.
Yeah, we could, but I'm just looking for the, oh, look at that. Look at that.
Yeah, 1010 is got a low count compared to some of the others.
I had no idea.
Yeah, if you do 4, you'll see it's even more extreme.
Huh. Wowee. Okay.
And I think that'll also apply if you do it 1-1.
What do you mean 1-1?
Oh, okay. No, never mind. That wouldn't make a difference. Sorry.
Okay, so this is, okay, I just want to put this in my summary. I didn't know that this doesn't have. Right. So now how does that relate to the length of the sequences? The fact that 001 is infrequent. How does that relate to the random walk?
In the run, once it's gotten started and it's eaten the original tape, there are certain sequences that can never appear.
What are they?
I don't know.
Well,
I'd
let's
have
look
to.
at one of the big ones. Okay.
Mhm. But basically, once you've got the tape with the front removed, you can determine what sequence created it. Because 00 is unique. It can only be produced by zeros and.
Okay, so hold on a second. So you're saying can one invert the sequence and find the init?
Yes.
And you claim the answer is yes. So
Uh-huh.
then I'd like you to give me a piece of code that does that, that eats one of these long sequences far, far, far out.
Mm-hmm.
You know what I'm saying? So
Right.
if I say here, TS direct evolve sequence, and I say this, comma 10,000, okay? And now I say SEQ2 of this equals this. Okay. Okay, 30,000 of those guys. Okay, so counts of SEQ2. Those are not actually that close to that's actually not as close as I would have expected.
Mm-hmm.
I don't know, those are not super close either.
But yes, I believe it's possible to go backwards.
Okay, but look at this. Do you understand why that's happening? And I have a different question, which is, if I look at the compressed sequences, do I still see the same thing? Right. So if I look,
No, not in the compressed.
okay, but how do I make the analog of this sequence in the compressed case? So you understand what this sequence is. This is every bit. Is there an analog of this where I'll just leave out every third bit? Or is there not?
For the randomness?
No. I'm asking. If I want to know what the sequence is, right? So this is a direct evolution, right? Where every step I'm adding, right? I'm adding things on to the back. You see what I'm saying?
Right.
I'm never deleting. I'm just my marker is just moving down here. Do you see what I'm saying?
Yes.
And is it the case that I can just look at every third element here and have enough information?
Yes. To create, yes.
So I can continue the sequence if I just look at every third element. So let's say I say for sequence 2 there, take sequence 2 every third element. So I want 1, -1, 3. Okay.
Mm-hmm.
Then I say counts of that. Okay, it's not quite 1-to-1. And then I do this, and I say partition this, comma 2, comma 1. Wow, I don't think they're the same. Those are definitely not the same.
Right.
Okay. Okay, do you understand this? Do you understand why these things are less frequent?
Yes, because there are certain combinations that are more rare.
Okay, so let's look at this case. Okay, so I'm going to claim that the mean field theory can give you this. Okay, so in the first approximation, right? Okay, so assume 0 and 1 are equally frequent. Okay?
Mm-hmm.
Then 0, 0, 1, 1, 0, 1 occur with equal frequency. i.e. equal probability for length +1 and -1. And 0 and 1 will occur. But now the point is that if what we're doing is a random sequence of these blocks, now the output is a random sequence of zeros of these two blocks. Okay, so that random sequence of those two blocks is random choice of this thing, comma 5, whatever it is, and then flatten of that, right?
Right.
Okay, so now let's work out what the probability of 1s and 0s is in this case, right? So we can think about that as a Markov chain, right? Where we're basically saying 0, 0 followed by 1, 1, 0, 1. And then the question is in that, right? So we have 0, 0. Let's see, we should be able to get a generating function for that thing. And the point is that 0, 1, once we see a 1, okay, so what are the possible things? So we've got these states in this thing. A 0, okay, so there a 0 is followed by a 0. Right, we have no further information. There a 0 is followed by a 1. Right?
Mm-hmm.
How do we get 0, 1, 0? Okay, so we can only get 0, 1, 0. Okay, so in here, right, we're just enumerating what are the ways to get different things, right? So here, if we just flatten this, okay, here's what we want to do. We want to say tuples of this. Am I right? How do we do this? Do you understand what I'm trying to do? I'm trying to look at what are the borders between these things, right? So if I draw the finite state machine, if I say, let me just draw it. I can draw it on a piece of
When
paper.
I've looked at that, I've saw two isolating cases, 2 zeros. We know that it's a 0, 0 group, or a single 0 means it's within 1, 0, 1.
Oh, let's see. It's not 1, 1, 0, 1. So I claim that if I label these, let's see, A, B, C, D, E. Okay, so I have a picture drawn here. So if I say that I go, how do we do a tagged edge? Do you understand my question?
I don't know. You mean a labeled edge?
Yes. A label like this. An edge that has a label on it, that has a tag on it. I thought there was a tagged graph or something that we could use to create that. Do you understand what I'm saying? One of these things that has a label on top there. Do you understand what I'm saying?
Mm-hmm. I think that's just labeled graph.
No, there's a different way of doing this. Where the heck is this? Where the heck is this? Unless it didn't make it into this version. Seems very unlikely. Oh, come on, where is it? Do you understand what I'm asking? Do you know what I'm talking about?
A tagged graph?
Yes, a tagged graph.
No.
Oh, come on. It's a graph where the edges are labeled. Edge tagged graph. There we go.
Oh, okay.
Okay, why isn't this described? Why the heck isn't that described? Okay, why isn't that described? Why on earth isn't that described? That's really bad, really sloppy. Okay, directed edge from A to B gets a 0. Directed edge from B to A gets a 0. Directed edge from A to C gets a 1. Directed edge from C to D gets a 1. Directed edge from D to E gets a 0. You see what I'm doing, right?
Right. Mm-hmm.
Directed edge, and obviously I wouldn't be able to do this unless I had this already drawn out on a piece of paper here. From E to A gets a 1. Okay, so that's this A.
Edge tag?
All right, there's our graph. Okay.
Mm-hmm.
Now, that graph, let's see. We need to figure out from that graph all the paths through this graph. Right? Am I making sense?
Yes. And you'll note that both single 0 and double 0 are unique.
So what does that mean?
That's one way of breaking out an output into the different portions, is to look at where the zeros are. Whereas there's multiple ways of getting 0, 1 or 1, 0.
Okay, fine. But I mean, so each one. I don't quite understand what. If you visit each node with equal probability, which I'm not sure you do you visit every node with equal probability in this picture?
I'm not sure.
Okay. Well, so
Well, obviously the edge of the center gets visited more.
oh, well, then the answer is no.
Mm-hmm.
Right? So, okay, if we're going to make a Markov chain out of this, right? We can look at the adjacency matrix here, and we will know how much each one is visited, right? Because if we say, what's the adjacency matrix of this? Okay, there's the adjacency matrix, right?
Mm-hmm. Right.
So now we want the exponential of that adjacency matrix, if I'm not mistaken.
Yes. Mm-hmm. There's some column condition. It meets the column condition.
Well, we want the eigenvalues to get the leading eigenvalue, right?
Right.
So, oh, for goodness sake.
CHOP will help.
I know that CHOP will help. I just don't believe in CHOP. CHOP is a horrible thing. There we go. Okay. So now that tells us the probability. How do we get the probability for each node? It's just dotting this into, yeah, these are permutations, aren't they? Are they? Not quite. Okay, I'm going to leave it to you to figure this out, okay? Because I think we can get an absolute analytical formula for what the relative frequencies of each of these different blocks is.
Okay. Try doing the eigenvalues. Ah, Fibonacci. How interesting.
Right. Could it be the case that our periodic blocks are paths through here?
I believe so. The square root of the golden ratio.
Yeah.
I had a suspicion that the 1-0 ratio would converge to the square root of the golden ratio earlier, but I thought that might be crazy to mention.
No, the 1-0 ratio is not going to converge to that, I don't think. Well, okay. Let's try this.
$131.2? No. Oh, right.
I don't think it's converging to. I think it's converging. To,
Yeah, it's nowhere near square root of
yeah,
the golden ratio.
it's converging to 1. Some other ratios might converge to that. My question is, are the periodic blocks simply, trivially, the all possible blocks that are 0, 0, 1, 1, 0, 1? Do you see what I'm saying?
Very possibly. You know, I think.
Hold on. So what was that thing for the post blocks thing, right? Do you understand what I'm asking?
Blocks thing.
Post cycles. Right?
Oh, yes. He was 1, 1, 0, 0, and 0, 1. And necklaces composed of those.
I'm sorry, 1, 1, 0, 1, and 0, 0.
Yeah, change the last 0 in the first to a 1 and the last 1 in the second to a 0.
Okay.
0, 1.
Okay, hold on. So you're saying that the cycles are given by all possible sequences of certain blocks.
Yes.
Okay, and those blocks you claim are?
In the post cycles code right above there.
0, 1. And you're sure that's not equivalent to all possible blocks of this sequence?
Yes. Right.
Okay. Okay, you need to prove this. I'm sure this is provable.
One thing worth pointing out, since we're getting Fibonacci everywhere, the eigenvalues, I think, is something worth mentioning.
Yeah, I know. I agree that these eigenvalues of what? Of this thing here.
Right.
Well, I know, yeah. Oops, 153. Okay, 1.27.
Yeah, that's a famous value in periodic tilings with things like the almond chair and things like that.
Okay. Well, let me just see what happens here. In 2105, well, actually 3138 over 2105, 1.49. So who knows? It's not the same.
Right.
Okay, but we should certainly be able to figure out from this. If we go down every edge with equal probability, right? Go down every edge with equal probability, what is the frequency of every possible block?
Right.
You know what I'm saying? So every edge, at every node, the exits are of equal probability. Actually, this is trivial. Right? So all this is saying is, at every node, we're just picking either the 0, 0 or the 1, 1, 0, 1 at random, right? And so what that's saying is, each one of these, let's see, each one of those has equal probability. So that means 0, 0, 1, 1, 0, 1. That means that we just have these cases. So if we're looking at pairs, right? 1, 1, 0, 1 has probability 1 to be like that. But then we either have this. Yeah, here, I claim it's just this. Okay, and then each of those You just have to please do the elementary math here, and let's figure it out. I'm pretty sure it's just this, and then you flatten these.
Oh yeah. Yeah,
Right?
that's how I'm generating. That's how I generated all the cycles, was this exact code.
Okay, fine. Okay, all right. So, okay, good. So we're going to work this out, and it's a little bit strange to me that we're not getting pure random walks, right? This means we don't get a pure random walk,
Right.
right? So even though the statistics of the wiggles up and down and so on, so what that means is if we were to look at let's see, where's the, no, we don't want the final state, we want the wiggles up and down. So this is
Oh, for example, 000 is impossible, or 10001 is
0, 0,
impossible.
0 is what?
10001. You can't have just 3 zeros isolated.
Right, okay. 1. Yes, I understand.
And
Okay.
you also can't have 4 ones.
Forbidden blocks. Okay, so 10001.
Mm-hmm.
It's forbidden. Okay, what is the first forbidden block?
1111.
Okay. Right. Okay, what's the next forbidden block?
I don't know.
Okay, so
Those I'd have
the
to
fact that
find
we
out.
can't have 1111 doesn't tell us squat, because the thing is checking things off 3 at a time, right?
Right.
That doesn't tell us anything. So what we want to know is, what's the first case? What is the first X blank blank Y blank blank Z blank blank ... forbidden block? You see what I'm saying?
Yes.
Can you figure that
Oh,
out? I'll figure it out here. Let me just get. So right now we have no forbidden blocks here.
right.
Actually, we don't actually know that. Hold on. There are 8 cases there, right?
Right.
Okay, so let's go.
And this is the compressed. I'm pretty sure you can go 4 and 5 and still there won't be anything missing.
Incompressed.
Yes.
Okay, well let's do uncompressed.
Yeah, anything with more than 4 ones will.
Okay, well hold on. SEQ 2 2 1. Okay, we got 4 cases there. Actually, what we just want to do here is we want to say length of that as a function of block size B, table B.
You'd have to remove the start of the sequence. Otherwise, you might get some.
I see. Okay. So let's say drop that, comma 200.
Mm-hmm.
Coolosaurus. Okay, it's pretty interesting. Okay, so already at this size, so let's just see what those are. 1, 2, 3, 4. At size 4, as you've said, so let's say keys of that, and let's say complement tuples 1, 0. comma 4, comma keys of that. Okay, so those are all forbidden. 1, 1, 0, 0. Okay.
Oh, right. 0010 is impossible.
Right. Okay, so this is the cases. Okay. Okay, so now let's look at the corresponding result when we say take SEQ um 1 minus 1 3. Okay.
Mm-hmm.
Ah, look at that. Okay, so there we've got at size 5. So let's do the corresponding thing here. Okay. So those are the first forbidden blocks in this case here.
Is that a long case? Yeah, that's probably long enough.
Yeah, I think so. So that means that this is up, down, down, up, down, never occurs.
Okay.
Right? So it's not really a random walk. So it has a slight deviation from random walkness. i.e., it is not precisely a random walk, even locally. Okay?
Mm-hmm.
Okay. I need a piece of chocolate, and then we're going to look at some. Then we're going to try and run some big runs.
Okay.
Try and build a thing which, because that's basically, yeah. Okay, I think we know the local information now. Okay, I'll be right back.
Okay.
Okay. Right. So, where is, I see.
Out of curiosity, what kind of chocolate?
Um, um, where's my device? Help. I don't know where that device is. That type of chocolate.
Oh, looks good.
I usually have the dark form, except when it's getting close to when I'm going to sleep, when I have the lighter form. Although I don't actually know whether it makes any difference. Okay. So, okay, so let's go back to the searches that we've done. Okay, and I've got to try to remember how we're doing those searches, right?
Hercule Poirot from Agatha Christie couldn't sleep without having chocolate first.
Okay.
Smartest detective in the world.
So they claimed. So he claimed, I think.
Yes.
Okay, so this is this here. And I had done, so I did all these searches, okay? So this is cases where it hit, it had 10 billion, am I making sense?
Each line represents 10 billion.
Each line two to the 20 times 5,000, it survived for 2 to the 20 times 5,000 steps.
Okay.
Okay. Okay, so that's 5 billion, a bit more than 5 billion.
Mm-hmm.
Okay, so these are the 5 billion survivors. Okay, now, unfortunately, I had to kill this before it was fully finished. Okay, so let's do the following. We're going to do a little scraping. Okay, so see this?
Mm-hmm.
Okay, we're going to do notebook import. Let's just see notebooks. Untitled 6, that's there. Okay, notebook import of Untitled 6, and then we're going to say an echo line goes to expression.
Okay.
Okay, we got that. Okay, let's do length, expos. Okay, we've got 1,100 of these puppies.
Okay.
And what we're going to do here, then oh, I see. Look at this. Look at this. Look at this. Look at this. There is a null comma at the end here. So if we do this, if we say cases in expr of null comma x blank arrow x, we should get survivors is this.
Okay.
Okay, there we go. Okay. So that's in Max's format, right?
Mm-hmm.
Okay. So first thing we want to do, oops, length / at survivors. Oh, that's crazy. That's because we're reaping. Okay. So this claims to be the number of survivors. This is the number of random initial conditions from
By length for 5 billion steps.
that survive 5 billion steps.
Mm-hmm.
Out of 10,000. Okay, number of random initial conditions out of 10,000 that survive for 5 billion steps. Yeah, right. As a function of initial size. And the initial size goes up in 8s.
Mm-hmm.
Okay. So here we say map indexed here. Oh, it's going from 16, so it wants to be first of hash 2 plus 1 times 8, and actually times 3 after that, because that will give the size in, you get what I'm saying?
Mm-hmm.
Okay. So that's consistent, I think. Let's do a fit.
I'm not sure if this is boring or interesting, because the length isn't all that. Well, it's length of like 50 to 1,000.
What?
What is the maximal length?
I like
Oh,
1,000.
it's a 30. Okay.
So according to the claim, the probability that you survive this is Catherine's description for me about random walks.
Okay.
The probability, the optional stopping theorem, apparently, is the key thing.
Okay.
i.e. the time to hit value A. Okay, so this is the time to hit 0. This is the distribution. All right. So I'm inverting this. This is the question of the survivors. Probability of loss greater than time u. Okay, the probability that it lost greater than time u. What's k? Oh, I see. K is the starting length. Okay.
Okay.
Len is the initial length. Okay, so that probability. Okay, so what we want to do here. Okay, so in our case, T is 5 billion, right?
Mm-hmm.
Okay. And then we're going to compute. This is supposed to be the probability. Most interesting.
You may as well multiply that by 10,000. Not bad.
I think we're off by a factor of 2 somewhere. Why would we be off by a factor of 2?
Good question.
But it's obviously close, right?
Mhm.
This is obviously what you would expect from random walks. I wonder whether we might be off by a factor of 2 because of something to do with this excluded blocks business.
Oh, if you look at those eels, half the time it wound up on a long highway, the other half of the time it didn't.
What do you mean?
For all the cases we did earlier, where we looked at everything, only half the time did it wind up on a highway,
Okay.
on an eel.
I see. So the claim is, so question mark, question mark, question mark, only half the time does it reach a highway.
Mhm.
But look, the highways.
And then the question is hitting a long highway, and those are much more rare.
Okay, but look, I mean, what do we have here? We have some kind of random field where, okay, model. Given every, yeah. every initial height, every initial length has a certain number of random walks, quotes, packed inside it. Okay, so let's just okay. Let's go back to actually analyze some of these. Okay.
Mm-hmm.
So there's going to do random walks. So let's.
I'm thinking that the shorter ones will be more interesting to study further.
The ones of these.
Yes, it's something like length 20 to 50.
Well, what we need to do. Okay, so let's do. Okay, so let's do this. How do we make an initial condition for this? What's the initial condition? Oh, 0. And then something. Really? Wait a minute. Oh, okay, that was at least different. Okay, what's a good example of one that doesn't just.
You could start with one of the eels of and use that as seed value.
All right, here, let's do the following. Tomorrow I get 64 more cores.
As in new cores, or they'll just be freed up?
New ones. It's machine.
Oh, wow.
Tomorrow.
Cool. Are they very expensive?
Not terribly, no. You know, I've asked Roger to make sure that this is done correctly. Oh my gosh. Wow, that's terrible. I've got 93 machines, but for some reason, some of them are not appearing. This is a case where I really want all the machines up and running. Ugh. Well, whatever. Okay, 70 is better than nothing. Okay, so here's what we're going to do. Let us go ahead and try and figure out. It's going to be inefficient, right? So okay. Find halting time, okay, of init will be basically, how do we want to do this? We want to say less than, see, what I'm imagining is that what we're going to do is pick up, okay, okay, look, here's what we're going to do. We're going to have I'm trying to figure out how we have a list of known Holtz states.
Mm-hmm.
Do you understand what I'm saying? So well, actually we know it. It's our cycles, right?
Oh,
It's
yeah.
either 0, 0 or it's our cycles.
Oh, yeah.
Okay. Okay, so our cycles are always of even length. Oh, no, wait a minute. How are our cycles represented in this compressed representation? Do you
They
understand what I'm saying?
they become the same thing, basically.
Well, can you give them to me explicitly? Because I want to generate our cycle. I want to test whether something is a cycle. You see what I'm saying?
Right. The post cycles gives the compressed form.
Okay, but if I say post cycles, what's a post cycles Q? Did you have one of those?
No, but that wouldn't be too hard to write, I don't think.
Okay, so tell
It's
me what it is.
basically you look at the first two items, and if it's 0, 1, you would keep going. If it's the first four items are 1, 1, 0, 0, you would keep going, and so on. So you'd basically break it up into those pieces of the, but there has to be some pattern matching way to do that.
Okay, what are you saying?
These are all combinations of 1, 1, 0, 0 and 0, 1.
One, 1, 0, 0 and 0, 1, you're saying. Okay.
Uh-huh.
So isn't that sequence? Well, here's a way to do it. I mean, we just say match Q. Sequence, is there a sequence match Q? No. Okay, what is it? It's this followed by this in any order,
Right.
right?
Or just one or the other.
How do you do this? So in a pattern matching, it's like, okay, well, first of all, look, here we divide it. Here's what we do.
Oh, and one simple first test is if the ones and zeros are equal and count.
Okay. If count list 1 is not equal to count list 0, then we're returning false.
Right.
Okay, so now we break it up into pairs. If partition, is it partition from the beginning? Yes, it is.
Yeah.
Partition of list, comma 2. Well, actually, the very, very first thing is if length of list, if not even Q, right? Length of list, am I correct?
Yes.
If partition length of list, if union, if not free Q, 1, 1, 0, 1, 1, 0, right? That's the
Yes.
case. If not free Q, partition that, comma 1, 0. Then it's false. Okay, what's the rest of the test? Well, look, a very simple test is if not member queue, how long are these? Okay, if not member queue, post cycles, length of list
Oh yeah.
over 2. Is this the right way around for member queue?
Yes. Hmm.
Comma list, then false, else finally true.
Let's see. Post cycles.
Oh,
The
didn't work,
post
didn't work.
cycles wasn't set up right. Because it just takes a number. The last list isn't needed.
No, it is needed. That's part
Okay.
of the
There.
number.
Okay.
Okay, so that's post cycle queue. So let's try on tuples 1 0 comma 10, let's say. No, comma 5. Okay, so then let's say select post cycle queue should give nothing. Yep, okay. So comma 6. Okay, so now let's say post cycle queue of 3. Oops, post cycles of 3. And let's say oh, for goodness sake. 199201. Okay, dandy. Probably correct. All right.
One thing I wonder about is post cycles of say 30, how long it takes.
Well, it'll probably take a while.
There might be a better pattern matching thing for things that have a length of say 30 or more.
Well, you probably can reduce it. Look, the basic point is, if you run it through the finite state machine, is it going to survive?
Right.
Okay, so let's write the finite state machine. It's easy enough to do. Right, from any node, right, so let's look at the finite state machine and let's just see what it does. Okay, so from this node, isn't it just basically this rule? It takes a 0. You don't know what node you're starting at.
Actually, I thought of a clever way of doing this.
Okay.
So you basically run the post cycle queue, and if it hits the last part, you basically do a snapshot of the item and you take the length. And then at 8 times that length, you do the test again. So say the length is 150. At 8 times 150, you basically see if you get the same thing again.
Why is 8 times going to be sufficient? It might not be exactly the right same value. It might be different, but don't these posts, don't they wiggle around by at least 1?
If
Oh, not on the compressed thing, not on the compressed thing.
Right.
Okay, well that's much easier than this. Okay, so what we're basically doing is we're asking, find halting time. We're going to take the most recent value, right? So we're basically going to nest while list, I claim. Do you understand what I'm saying? We're going to pick up the most recent value and we're going to compare it with the value before it.
Mhm.
Okay. So init, comma, we can just double. Let's just double each time. Actually, we could just do a do. Go ahead.
Suppose you do a number of steps equal to the length each time.
No, it's very, very inefficient. We don't want to do that.
However, if the item was a cycle item, it would return itself.
I don't give a damn.
Okay.
I mean, we could do that as a test for whether it is a cycle. Yeah, we could do that. We could do one iteration that is just a test for whether it is now a cycle.
Especially if you set it off to a core, to a different core.
Doesn't matter. Why would it do that? Why would it matter? It just doesn't matter. So look, the test for whether it is a cycle is just to do. So remember, this is of the form 2 comma whatever. So what is this going to do? So is it going to keep the same phase or is it going to change phases?
It could change phase, but I'm thinking right now your runs are basically linear, right? Oh, you're doing a 10,000 on different cores.
Yeah, but I'm not going to do that. I'm going to do a systematic search here. That's what I'm
Okay.
trying to do. Okay. So let's do the test. Okay. So what happens for the 0, 0 case? What is that case? What does if the thing just dies out completely, what does it give? What does post final tag system give in that case? Do you understand what I'm asking?
Just run of zeros, I believe.
How many? Is there going to be a problem with this algorithm? No. Okay. So here's what we do. So we say tag system 2 to the n. Okay. And we say do this.
Oh, well, if check and if it's all zeros, stop.
No, I understand. I understand. So this is new equals this. Actually, I want to say old equals null. Okay, so now we say new equals this. Okay, did you understand what I'm doing? So now we say, wait a minute, old equals new. Whoops, what are you doing? You're making bizarre noises in the background.
Keeping my dog away from something.
Okay, old equals new. Okay, right? This makes sense. So then here we're saying if lost of, oh no, now that's the previous value, that's this value. You know what? All we have to do is check whether they're the same size. If they're the same size, it's cycled. See what I'm saying?
Not necessarily.
Why not? How could it not be the same? How? If they're the same,
I believe on the eels, there are many cases where you have the same length.
okay, all right, fine. But if they're actually okay, so then what you're saying is, so you're saying we don't even have to check that. We just have to check this, and then we run it for, oh, but we can't always do that because they're not always a multiple of 8 in length.
Right.
I think we're going to use the heuristic of did it grow by any factor in this. I think we're just going to use this. Okay.
Okay.
What are you doing? You're making this bizarre noise. I'm driving me crazy.
Okay.
Well, this.
That might be my dog eating in the background.
Okay, fine. Okay, so basically we're saying, while this isn't the case, keep going. No, we say do this if old, if length, well, if it's exactly the same, but that's not good enough, right? If the length, I'm just going to do the heuristic. Find heuristic halting time. If length how did I find the exact halting time before? So there, I'm using find transient repeat, I think.
I'm guessing that's expensive.
Very. Well, I mean, it's not. Yeah, there's find transient repeat there. Okay. We're just not going to get the exact value because we've got these 8s lying around. Okay, if length of last of old equals length of last of new, return n. Well, let's just throw n. Otherwise, n goes up to max. And if the do fails, then we say, let's say infinity or too big. Okay, and then we catch here. Okay, so that's find heuristic halting time. So let's just try that on a few things.
Okay.
Oops, no. Big problem here. N, we need to start n at 3, right? Because its minimum value is 2 to the 3.
Okay.
Okay, so now we say find heuristic halting time slash at tuples 1, 0, comma 4, 5, let's say. Can we do, yeah, we can do these.
Yeah.
Oh, for goodness sake. Ah, right. I want to do this. I want to say 0, comma that. Right?
Oh yeah. Hmm.
Wait a minute. Oh. I don't know if that's correct or not. I have no idea if that's
Try it
correct.
with try it with tuple 6. Yeah, there's something wrong.
Okay, so then the new let's echo that. They're all fixed length. None of them got any bigger.
Try running the post-tag system final state on something.
On what thing? On that thing there, for example.
Yeah. Uh-huh.
Well, it's got to be 2 to the n, so let's say 2 to the 4. Okay, well, it may just nothing may happen here. Okay, so let's do this. Let's say 5. Come on, what's going on here? Wait a minute. Maybe they have to go for longer. No, it's for double the size, right? So this will be double the size. Am I making sense?
Uh-huh.
Well, those are all the same. See that?
Mm-hmm.
Let's get rid of the echo for a second. Let's just try running. Let's try running that to 8. And let's try running this to 6. Oops, not what I wanted. Okay, why do none of these grow?
Yeah, that doesn't make any sense to me.
Okay, what's going on here? Is this just full of crap? Let's hope it isn't. Let's really hope it isn't. Okay, 0, 0, and then hash. So let's say this is, let's say 16 steps. Tuples 1, 0, comma 5. Oh, come on. What the heck? Is this just completely broken? Oh, come on. What is this nonsense? Come on, Max. Didn't he even try this? Okay. Where's the thing that's supposed to be working with this? Did you understand my question?
The piece of code other than that?
No. The thing that's loading this up and getting it started and so on. Do you understand what I'm saying?
Yes.
Okay, so let's take a look at this. This is probably full of crap. Okay, so we've got this get post tag system thing. I hope he didn't say, I mean, I hope if there was something else to be installed, that he installed it. Needs post tag system. Let's see whether it works for this bigger case.
Try changing it to 10 million. Okay, that looks reasonable.
Well, so why are these not doing anything? Maybe none of them do anything. Well, let's try this. I mean, let's go 0, 1. Okay, so let's go 1,000 steps here. Okay. And
They're
then
all returning
say,
the same thing.
or returning their initial condition.
Right.
How can that possibly be right?
Maybe it has to be a certain size before it works. Go down below again to that piece of code we ran for 50,000. Yeah, copy that and try cutting down the length. Okay, that works.
How do we know it works?
Well, it does something. It doesn't return what you put in. So let's put in more steps.
Well,
And
look, even at 16 steps, it's not of a different length.
that's okay.
I know, but let's try 32 steps. Okay.
One thing I'm wondering, if you cut down the length of that to like 5 instead of 16, whether it'll stop working.
This here.
Yeah.
How many things is this? 15. Okay, so let's take one of these out. Oops. Seems to work.
No, it doesn't. It's acting weird now.
Well, let's find out what happens.
Try length of 10.
No, wait. TS mod. I've got this thing that does mod evolve stuff, right? Do you understand what I'm saying?
Mm-hmm.
Except that my version of this isn't this because Max didn't set it up correctly. Sigh. Well, this has different behavior. Except maybe every 8. Let's see. Zero, 1, 1, 0. Every 8 steps, every 16 steps. Oh, wait a minute, is that the same? That's just complete nonsense.
Right. I'm thinking there's a certain length where it doesn't work correctly. And if you go more than that length, it works fine.
Well, what do you mean more than that length?
I'm thinking there's some minimal length built into his code. So if you go to like a string of length 15, it'll work fine.
No evidence that's working fine.
Right. That looks the same. And no, it's different.
I can't believe this. You know, he's got all this crap about some. Let's see, 9 steps. Is that going to work? Yes, 8. Has to be more than 8. Whatever. How about he gives an error frigging message if it's less than 8? How about if it gives an error message? How could that say too big there? Is that bigger than 2 to the 20th? Do you understand what I'm asking?
Right.
Okay, so that's the fourth tuple. Okay. So let's say this one, TS direct evolve list. This, comma, 0. Actually, TS direct evolve list. No, TS mod evolve list, right?
Yes, I think so.
Full of shit. I mean, it's just not working, right? Because this goes to, this just dies. Oh, maybe it doesn't. 11.
Try it to 10,000.
No, it's dead.
Yes, you're right. It hits a cycle.
Right, but maybe that cycle is not being detected here.
Mm-hmm.
So why would it not be detected? It's at size 2 to the n. Oh, look, it's different sizes. It's wiggling up and down.
Right. That's a feature of the cycles.
Right. So does it wiggle only by 1?
Let's see. I think so. We could try them and find out. We just do the same thing on the cycles and see what their behavior is.
Okay, there we go. So at least the claim here is this makes sense.
Yeah.
Okay, so let's do the 10 case. All right, and now what we want to do is basically, let's just histogram these things.
Actually, there's something here that doesn't make sense to me, and I thought we would hit an eel at this point.
This is exponential.
Oh, okay.
So we did hit an eel.
Okay.
Right, the 13 is a good eel.
Okay.
So let's find the max here is 13.
And I see at least 4 13s.
Yeah. So now it's interesting.
No, that's also interesting.
Okay, so something was bigger than, let's go up here to, let's say 25. Oh, wow. Let's go find that guy. So something was bigger than 2 to the 25.
Okay. Which is a pleasant number.
Should we go to the 2 to the 30th and just see whether it survives? Well, let's find out which one is too big for that.
Mm-hmm.
576. Here we come. What? Okay, there we go. So now, well, let's just do a find heuristic. I mean, it doesn't really matter. We could do this. We might as well do it to 1 billion.
Interesting.
Oh, it is interesting. Okay, so this one is of length 13. Okay, so now let's go use our equipment over here. That's every 2 to the 20th. So this is, let's do 1,000 of those. Oh. What just happened there? Well, I don't understand what happened there.
Try running that one for maybe 100 steps or something like that.
Well, this one claims that it wasn't stabilized. So if I just run this thing here, actually, why don't I do this?
Yeah, let's do a much
This is a
shorter run
test
and
plot.
see if it's
Look, test plot, init, Inca, init, max, Inca, and Inca is defaulting to 2 to the 20th. Okay.
Mhm.
Okay, so test plot of this, let's say the max is 100 and the Inca is 1,000. What? What the heck? What the heck is going on here?
right. I want to see a short run of like 1,000 steps on that one.
Let's do these incas of 8. What the heck is going on? Okay, so let's do this. Let's say, what am I going to say here? I'm going to say TS mod evolve list this thing, comma 10. What happened here? Oh, damn it. Damn it, damn it, damn it. Oh. Well, the problem is look, that's the problem.
Mm-hmm.
Actually, the real problem is it's differing by 2.
This could be a non-standard cycle, so this could be a cycle we missed.
Okay. Well, let's see. Okay, so let's understand that, what this cycle actually is. TS mod evolve list. Well, okay, so this particular thing is just from mod form. Should I do it with the do I need to do it with the full thing, or can I do it with
No, you don't. Let's just see what happens if you run it for like 10 steps. Let's see if it breaks into the beads that we know about.
Well, look at I don't understand.
It does. The 4th case, 0, 1 is a bead, 0, 0, 0. Oh, no, it doesn't.
Well, here, let's run it for 30 steps or something, and let's drop the first. Let's run it for 100 steps, and let's drop the first 80 steps.
Oh, well, let's just do a union.
Okay, well, fine. Of which? Of the first elements, ignoring the residues?
Sure. Or the whole thing. Yeah, it doesn't matter.
Well, the union.
Okay, it's the same.
Well, actually, that's non-trivially interesting. I mean, let's do 200 steps, and let's drop the first 80, and let's union that result.
Okay.
Well, that's rather a lot of stuff.
Huh. Okay, that's a very complicated cycle.
Like 40 cycle. That's suspiciously long. I'm going to done this for 1,000 steps. No, it's reasonably convincing. Okay, so let's do the following. Let's run it for 1,000 steps. And let's say find transient repeat. This thing, comma, let's say 5. And then let's say last of this. Okay, there's the cycle. Okay, what can you say about this cycle?
It's not on our list.
Shoot. Well, that's bad.
Oh, it's good in a way. It means that there is behavior that's not completely explained by the cycles in that Fibonacci list.
Yeah. Okay, well, let me just add this to our summary. Okay, fine. All right, so then
basically this is a cycle that does not have a simple generation of itself.
Okay, well now All right, so I'm gonna make
Oh, and more importantly, a length 13 can generate a 40 cycle.
yeah. So what's your point?
All the other cycles we know about,
Oh,
you
even
need the length to generate a cycle of that length. This is a cycle, or this is a list that generates a longer cycle than its length.
okay. Well, length, but it's also a length 13. They're not supposed to be length 13 cycles. They're not supposed to be cycles for lists of length 13.
No, there are. If you do post cycle 13, there's a whole bunch.
Okay. Okay, but you're saying
That give 26 cycles. Or sorry. Yeah, okay.
right. So this generates a cycle longer than twice its init length.
Mm-hmm. There's also some 14s in there.
And where?
If you do the list of lengths, some of them are length 14 and 12.
This is length. Oh, I see. So so we didn't see the length 12 because we didn't consider the other phases.
Right.
Okay, so we're only considering. So what we probably want to do here is we'll probably want to consider all the phases. Okay, so we want to go over tuples, and then we want for each of those we want to do. Let's do this more carefully. Okay. So remember here we've allowed a delta of 1. Okay.
Mm-hmm.
Okay, so we'll probably want to adjust that delta. Okay, so then here, let's do the following. Okay, so we want to map over the tuples, and we also want to go here, p from 0 to 2, right?
Mm-hmm.
Okay, so we'll go 9 here. Really? It's already 13, okay. 10. 13, okay, 11. 14. 12. 14. 13. Okay.
For our cycle output here, let's see a rate plot of that.
Of which? This thing here?
Yeah. Uh-huh.
How do you want me to do it? Do you want me to flatten
Just
everything?
a rate plot of the first.
Why don't I flatten them? Well, okay, we can do first. Does that work, or does it completely jagged? Okay. We might want to remove the, I mean, if we remove the, yeah. Okay, look, let's get this working across the parallel machines.
Mm-hmm. Mm-hmm.
Okay, so if I say position in res 13 of too big, what? Max res 13. What the heck did we do wrong here? What did we do wrong here? Don't tell me this thing isn't working on the parallel machines. Oh, come on. Come on, you can't be serious. Parallel map monitored.
Has this code gotten to those machines?
That's what Roger was supposed to do today.
Okay.
Where's an example here where we can just test it? That does appear to be correct. So why would find heuristic halting time not work there?
Good question.
Well, do you see what it's doing, right?
I think so. Why is it returning 444?
Oh, because it's got a table of P over P equals 2. Okay, why is this always returning 4?
It's a very good number.
Oh, shush. Let's just try this just in case. What? Okay, let's look at this more carefully. Okay.
Is your code on those machines?
It doesn't matter. It's automatically put there.
Okay.
If Roger made this code 12-3, I'm going to go nuts. I'm just going to go nuts. No. That's okay. What is going wrong here? No, it has to be, the code has to be there because otherwise it would be, What the hell is that? Oh yeah, I don't get it. I just don't get it. I mean, let's try one of the bigger ones that we know doesn't terminate quickly.
Okay.
Where's one that is known to be, where is it? Do you know where we have the
Well, one thing you do is just take a long, well, a string of.
No. We're going to do the actual case, okay? So we don't have any confusion. Okay, here we go. This is one. What the heck? What the heck is going on here?
I don't know.
Well, here, let me try one thing. Init max delta. Oh yeah, I don't get it. I don't understand what's wrong here. Okay, so let's just do the following. What? Wait a minute. What just happened? What just happened? Let's see whether this works. Does this still work? Or is this broken too?
That works. Try the tuples 14 case.
Where?
Instead of 10 at the end, 14.
Okay.
I'd be curious to know where the 20 and the 2
I don't
are.
care. Doesn't matter. Doesn't matter, right? Because what's happening here, this case is failing. Why? See what I'm saying? Unless that initial condition is confused somehow, unless Max has broken something here. Do you understand what I'm saying?
Wait a second. The setups are different.
What do you mean?
In your max flatten here, you've got the okay, that's different. Okay. You're mapping that to tuples.
Okay, why did the heuristic time for this one fail? I mean, I think what we have to do here is look at TS mod evolve list. of this thing comma 1,000, and then let's say, oh, for God's freaking sake, that's wrong. And then let's say length of first of hash. Okay, that's what that does. So how come could it be the case where it doubles? Go ahead, what were you going to say?
Maybe that condition you put in for the difference is what's changing this.
It's not, because I already put in, I put in the case of 1.
Okay.
See this case here. I mean, unless I got it wrong, let's look at it. Abs of length is less than or equal to delta.
Okay.
Delta blank colon 1, right? That means that its default value should be 1.
Right, right.
Well, let's try delta is 0 here. See whether that affects the values here.
Okay.
Oh, for God's sake. What the heck is going on here? I don't understand this at all. Okay, let's go back to find heuristic, whatever, because it was working in these other cases, right?
Right. That's why I wanted to look at 14.
All right, what's going on here? Something stupid is happening. Okay, so here we have, okay, let's do this. Echo, post tag system final state, 2 to the n. Okay, so let's see what happened here. Well, they happen to be the same length is basically what happened.
Okay.
How can that be? Why was it? Okay, so all these results are nonsense. I think we need to start with at least 4 or 5 here. Yeah, that's fine. Okay, let's put in a min here. I think that's what's messing us up. All right, let's try these now. The heck is that? What the heck is that? Oh, for goodness sake. No, don't tell me they're all 6.
Yeah, that doesn't seem right.
That's bullshit. It's just bullshit. It's just completely wrong. It's just complete bullshit. Okay, what the heck is going on here? What is going on here? I think something is going wrong with Max's code.
But it works outside of parallel.
I think it's wrong on I think it's broken on the other machines.
One thing that might be.
Wait. It looks as if. Let me just look at something here. That worked.
Mm-hmm.
Let's look very carefully at this code. Do old equals new. If old is not equal to null, let's say like, let's do our case of 9. They're all equal to 0.
Right.
Because they're all identical. How can this be? Okay, do old equals new. New equals this 2 to the n, right?
Right.
So that's 32 there. So at this point, if we echo old new, okay, and we do this not in parallel, we just say map. We're going to get a fine result. Okay. Now let's do, okay, so here, now let's do parallel map, the same thing. Let's just take the exact same line and do it with parallel map.
Right.
For God's freaking sake. I know what happened. Oh God, this is so stupid. This is so freaking stupid. So stupid. This is really dumb. Really, really, really dumb. Really dumb. Monumentally dumb, I would even say. Like spectacularly dumb.
I can't wait to hear what it is.
Just dumb. Just really dumb. It's because of the way these Packlets are installed. I suspect we have to do this first.
Oh.
But we shouldn't have to do that.
Yep, you're right.
stupid, stupid, stupid. You know, sometimes, whatever, my patience is not exactly a virtue. It's not. I should be much less patient. I will not have my time wasted.
Oh, I wonder where that 16 is.
Yeah, let's find it. We'll find it in just a second. Unfortunately, we've now got yeah, I mean, the problem is we've now flattening it with 0, 2 there. You see what I'm saying?
Right.
So we have to say, well, here, what we could do is we could have another version of this where we say, forget that, forget that, forget, well, actually, we could do catenate.
Or just find 16 because it'll be in one of the groups of 3.
I understand. So you just say cases. No, but that's no good. I don't want that. I don't want that. That's not what I'm trying to do. Hold on. Oh, stupid, stupid, stupid. I thought I was going to do that. Yeah. There it is. Okay, so that one, if we do our, where is it? Our test plot. What the heck?
I bet it's hitting that same case.
But why did it say 16 there? Oh, maybe it's only 2 to the 16. Yeah, it's only 2 to the 16. It's nothing.
Okay. That looks like a 4 cycle.
Well, 4 cycle with respect to, it's a much longer cycle. You understand what I'm saying? But it's just not. Okay, let's go up to 30 here, or at least 25. Let's have resource system. Okay. Okay, too big, have 2.
You could copy that cases thing you've got right above there.
Yeah, I know. Okay. So let's say test plot hash 200, 1000. Let's just say 100. Slash at that. What? $128. Okay, so those probably, yeah, those are the first of the funkies.
Mm-hmm.
Okay, so those, right, they're the first non-standard cases.
Okay.
So you should look at those. Okay,
Mm-hmm.
I'll send those to you.
Okay.
All right, now the claim would be that if we do the same thing with 2 there, we're good. Okay, let's go on to 12. Okay, 13. Actually, what I should do is compute these things locally, right? There's no reason to have, in that table, there's no reason to have anything other than, do you get what I'm saying?
Uh-huh.
There's no reason to actually send the tuples over, right?
Right.
So instead here, what we want to do is integer digits okay, with n equals 15. And here I just want to say integer digits hash to n, correct?
Yes.
And there I just want to say range of 0 to the n minus 1.
Right.
Close for the width.
You could also do a double table.
No, I can't because I can't use the monitoring mechanism if I do that.
Okay.
What's happening? Okay, 3 too biggers. You know, there's a certain argument that I should just rewrite this function to just say echo.
Oh, that's an idea.
is a bit low tech, but it should work. Okay. Okay. This starts to be a more jolly character.
Mm-hmm.
I think I've seen this one before. I've seen this one before.
So you have a smaller generator for it now.
Maybe. Let's take a look here. So let's say this is let's do, is 1,000 divisible by 8?
Yes. 125.
So let's see, what we've got there is up to 2 to the 20th. That's what we've got there as a million. So this is now already at 30 million. Let's go to 100,000. Huh. Okay, it's splatteroo. Let's pick up the other ones, take a look at those. That's much less interesting. Okay, so let's do it. Go down to 1,000, 1,000. So that's 30 million.
Mm-hmm.
And this one is a different shape and about 4,000. Okay, so let's look at this one here. So these are 3 quite different highways. Well, maybe
Right.
2 or 3. I don't know how many. Those
That's
2.
the same one.
Right. So this is the first really serious champion.
Mm-hmm. I may as well change that to 4,000.
Well, I'm just gonna how many steps is this? Okay. So this is 3,000. This is 30 million.
Yeah, that one dies in 2020, it looks like.
Right. It's viral attack.
And earlier we were noticing that there was a whole bunch of things in math that happened 100 years ago, probably because it was right after a war and a pandemic. That's when they finally started opening up. And
Oh God, you might be right. Well, that'll be exciting. That's a good
In
point.
which
I
case,
don't- yeah,
people will need math software really heavily
Let's
this
hope.
year and next.
Let's hope. Okay, let's keep going here. Let's go for 16. And I'm going to increase our, let's go at least to 28. How big is 2 to the 28? Okay, so how big is this guy here? 4,000. 400 million. Okay, so that's a little bigger than that. So we'll still catch that guy at 2 to the 28.
Mhm.
Okay, so let me just check that. Yep. Okay. Good. All right, let's go to 16. Oh boy. Okay, 18 of these. All right, let's take a look. See whether that's the same highway, for example.
And those 26 cases are pretty interesting as well.
Maybe. Same one. Same one.
Uh-huh. Yep.
Okay, so what we should be doing here is just measuring. Are we hitting the same? Well, okay, hold on. Let's just get all of these.
One thing you do instead of just an echo, you could do an echo and that plot. That way all the plots would happen automatically.
Yeah, that's a reasonable thing to do. I think that's what I did before, actually. I think that's how I got these.
Oh, okay.
But let me just figure out how to scrape these. That's kind of crazy. But I agree that that would be a reasonable thing to do.
And it's as a business strategy, I think it would be good for you to claim that it's going to happen again, this 100-year cycle. Because if you claim that really important discoveries are about to be made for people that have the right software.
That's funny. That's funny. Yeah, right.
And that way, these history projects you've been doing, it can be part of your grand plan.
Yes, right. Well, that's an amusing idea. It's an amusing idea. I wrote myself a note. All right, let's see. Echo init, comma.
Right.
Okay. I think that's going to be this picture over here.
Okay.
We'll see. Oh no, those are random, actually. Those are random ones. So this is going to be more interesting.
No, it's not giving the plot.
Oh, that's because I did the wrong thing here. Find halting time plot.
And they all look very similar.
They all look the same. Okay.
Well, that saves you a lot of time.
All right. So let's do the following then. To go further, let's go to 17. And now I want to go up. Let's see, that's 4,000. So 2 to the 29. Let's go to 30. There.
Okay.
Okay. Actually, let me see. 2 to the 29. And these ones were 4,000. What were they? What were they equal to? 4,000 times 100,000. Levelized as 400 million. So this would go a little bit beyond that one.
Mm-hmm.
So 2 to the 29 would go a little bit beyond. So there's a decent chance that we won't.
It's the same one again. So this must be a very popular highway for small
Well,
initial
but I don't
cases.
understand why we hit that highway, given that it is, I don't understand why we hit it, because we've got, I thought I just said to go more steps than that highway. See what I'm saying?
Right, right.
Maybe we miscalculated here. 2 to the 29. Well, here, let me look at this picture. Okay. Okay, this dies at 3,500. Okay. Oh, I think we're off by a factor of 2 because we're going a second round. See what I'm saying? We're going
Oh, I
twice
see.
as far.
Okay.
Truth is, we already know it's not dead. We could actually simplify this a little bit, but it probably doesn't matter given. Okay, so let's go 30 there, and let's try and go to n equals 18.
Okay.
Okay, nobody survived. Okay.
The 30, but we had 70 that lasted the 30.
Sure. Big woobly doobly. Okay. And let's try again. I think it's good that we're able to systematically look at these. I mean, you know.
Oh, yeah.
Wait a minute. Did we scraped those survivors, but did we counted the number of survivors, but we haven't looked at those survivors to see if they continue, so to speak.
Right.
But it's more interesting to do the systematic thing, because I think we're finding quite a lot of really long ones here.
Mm-hmm.
Okay, so when we have really long ones, the question is, can we store something which is a checkpoint where we feed in, where we check, did we get this particular thing, or is that not an efficient thing to do? At one of these 2 to the n's, can we check whether we have something which is on a highway? How do we check for highwayness without doing a giant thing with a gigabyte of memory and things to store what's on the highway?
Good question. I've been wondering about that. Oh, we got something.
Well, you got a little puppy there. Okay, let's look at that puppy. I have a feeling we've seen that one before. If that one survives, hats will be eaten. Okay, let's go look at these. Okay, so we already know they survived to the 30th, right? So
Right.
we might as well go, let's see, 5,000 steps to 1,000,000. Let's see what that does.
And I recall seeing a picture of you with a newer hat from one of your hiking expeditions.
This one is not the one I said I would eat my hat if it survived. That one is okay, we've seen this one before.
Okay.
Okay, so that's the smallest. Let me record that one. Yeah, we've definitely seen that one before. Whether we had the shortest version of that one. I think that's our champion. Oh, 20 million steps is nothing compared to this, right? This thing
Right.
is 2,500 million.
Mm-hmm.
That's 2.5 billion.
Right.
Okay, and this guy here,
Oh, it's going into that weird cycle.
well, that may be a
Or-
cycle bigger than 2. You see what I'm saying? Let's
Right,
go down. Let's go down a whole lot here. 1,000. Let's go down 100,000 there.
Oh, because it is doing a whole bunch of interesting stuff before it hits the cycle. You're right.
Okay, so here, so let's go 10,000 there. Well, I think that's just a 6,000. Let's just check whether that was smaller than 2 to the 30th, right? So that's 6,000 times 100,000. That's 6 billion.
Okay.
So it's bigger than, right? It's just a little bit smaller
Okay.
there. No, is it 6 billion or is it something smaller than that?
Looks like 6 billion.
No, look, it's 6,000 times 100,000.
Oh, right. Yeah, it's definitely
this one-
smaller.
So this one is 600 million.
Mhm.
And this is on the order of 2.5 billion. Okay, so this one, I think, might have some kind of weird property of having okay, final
Yeah, that's what I was about to suggest.
system final state. This thing times 6, well, let's say 700 million.
Right.
Okay, let's take a look at what that does step by step.
Right.
So TS mod
So probably just a list plot
yeah, and
or an array plot of 100 steps would probably be fine.
well, here, let's just say list step plot of length of last. What the heck? Oh, for God's freaking sake. We have to put the things at the end to get this to work. Right?
Oh, right. Mm-hmm.
But what do we put at the end? Do we put, that's a 2. I don't know what to put at the end. I put blank blank at the end, presumably.
Yeah, probably.
Can I do that?
Yeah, it's. Mm-hmm. Okay.
Well, here, what do I put at the end here?
500. Interesting.
All right, well, let's try running it for more than 100 steps. Let's try running it for 200 steps.
Right.
Wait a minute. Wait a minute. Let's try running it for 500 steps. Wait a minute.
That's interesting.
Do you see what I'm seeing? This isn't periodic.
Well, it has to be periodic eventually.
Why?
Pigeonhole principle.
Okay. Let's find out its period then.
Right.
Okay.
But yeah, that is an incredible find, I would say.
Okay, let's go get how many steps? Let's go get 5,000 steps, and let's say find transient repeat of that, comma 10. That's not periodic.
Not yet. This is a really weird sequence here.
Okay. How long can it go without being periodic?
Length 2 to the power of the length.
All right. How do we get, I mean, we can use the fast code to sample it.
Try also an array plot on the, do like 200 steps and just the array plot of the first.
Okay. Well, here, let me just record this. I think we should
That
get.
is bizarre.
Let's get this more. Let's do the the rotate left thing. Okay.
Mhm.
Map indexed. Rotate left. Hash, comma, first of hash 2. Is that right?
I think so. Maybe it's rotate right.
Why do you think that? I think this is correct.
Okay.
What is going on? Well, first of all, do we think this is the correct thing here? Okay, so this isn't staying constant size. Look.
Right.
It's growing very, very, very slowly. So what we should see here, okay, let's do this. Well, heck.
Oh, that's the length of last. You need the length of first.
Oh, well, this is wrong. Okay. So wait a minute. So this is completely wrong. So what I was doing here was just completely.
Oh, right. Mm-hmm. No wonder.
Okay, so
but
max
it still seems to be something weird.
Well, that's length of first there.
I see. Okay.
That's not that weird. But you see, but this is wrong because Max's code will give a different result, right? Because we don't know how these residues work. Do you understand what I'm saying?
Right. Mm-hmm.
See there, it's dead.
Right.
Well, so I mean, this is all nonsense, basically.
Right.
Okay, this is all nonsense. I just delete it. Doesn't make sense to keep this. All of this stuff is amusing but not relevant. Okay, so here we've got to know. So first thing tomorrow, you got to figure out from Max how this works with the residues. Okay.
Mm-hmm.
But here, what we can do, which is really dumb, is we can just do this. Actually, I don't know. Does he have a post tag system evolve?
I don't know.
There's no documentation, of course. No, nothing. Okay, so We just don't know how this thing is supposed to work. Here. Okay, so this is the periodic cycle that this thing is in, at least mod 8.
Okay.
Right, so
What's the length of that?
well, I don't know, but array plots last/at %.
Oh, okay.
It's very cycly.
Oh, we have this. This is a standard cycle.
But
Right.
remember, this is a length. Okay, so it's probably just a glitch of what we mean by 2 to the 30th.
Mm-hmm. But we do have that cycle in our. That's a standard cycle.
Okay. So let's say 2 to the 21 here.
Mm-hmm.
Should we go 31 here?
I think we can leave it 30.
Okay. All right, and this is probably the last one for the evening, and then I'll leave some running overnight. I mean, tomorrow I will be able to run about twice as fast, for what it's worth.
And I suppose I need to find a cycle detector that's reasonable. It's at least one that will break down our known cycles.
Yeah, it'd be nice. But I mean, I think the more interesting thing is to find a way of detecting if we're on a highway. Because I don't know what we spend time on here. You know what I'm saying? I don't know what's taking time. The number of long ones that we're getting is not super long. It's super large.
Right, right. Those look like the ones we saw in the last run.
They're all the same. Yeah, they're all the same. Nothing new under the sun.
Yep, we have all those.
We have them all. So I think we go to 2 to 31, and we go to the next level.
Mm-hmm.
And I think we're collecting. These are big eels. N equals 22, 2 to the 31. Okay, eels away, so to speak.
And you could probably set up your larger run.
Yeah, I will. I mean, the larger run, we might as well do, what should we do? We'll just do 23, 24, et cetera, et cetera, et cetera.
Yeah, you could probably just put a do loop or something around.
No, I don't do that. I don't want to do it because of various things about how this will mess up. See, what's happening here, which is really stupid, is this is going over all those giant number of parallel thingies, right? It just sent that amount of data.
Right.
And this says it's going to be finished in April.
Okay.
Okay, time machine is going backwards. February, oh good, it's February 9th. Okay, things are speeding up here. All right. Unfortunately, they're up. Okay, so this is actually, we're going to get to this one. Well, all right. I will set up the next piece. Seen that guy before.
Yep.
I kind of think we should say to the 32 here for the
Yes. And change the second 23 to 24.
Thank you. I think we might get one new one here.
Oh, and go up to that unusual cycle and copy that and send me that.
Which unusual cycle?
The one that had length 13, but a cycle length of 40.
I already
Okay.
sent.
Okay.
Boy, this is rare here that we're seeing. Okay, more of the same.
I'm guessing a lot of these highways are also like ceilings that are hard to get past.
What do you mean?
They basically have lots of on-ramps, so it's hard for a car to maneuver past them.
Yeah. Except we're not seeing a lot of bushiness coming up with those things. They don't get bushy very quickly.
Right.
Look, I think we're not going to find anything that escapes.
One thing that might be interesting to track, we've got a whole bunch of these that lead to the same highway. It might be interesting to see whether they all converge to the same base case quickly.
Yeah, I understand that. That is worthwhile. Yeah, I agree. I don't know how we figure that out, though. I mean, it depends on how quickly.
Oh, I'd say you just
steps. Then it's
yeah, that's what I'm thinking. You just run each of these 100 steps and see if they merge.
Right, if that's the case, if they merge by 100 steps, then obviously after we've run one of these for a while, we should just go back and run it for 100 steps and see whether it fits one of the known highways.
Mm-hmm.
You're right that a highway is a better term than freeway, probably.
Or in the better term than eel, maybe. And tollway might also be good because you can't get off.
Well, that's why I was calling it a freeway.
Okay. Tollways have fewer exits. But highway is also good.
Bizarrely American, the tollway story. I didn't even know they had fewer exits. They only have fewer exits in like New Jersey because they're trying to, I don't know what. Who knows?
Yes. Oh, I grew up in New Jersey.
Yeah, I vaguely remembered that.
You must have driven through there.
I lived in Princeton for a while.
Oh, okay.
So I
Yes.
drove through there. Okay, I think it's, well, we got just a few minutes left here. Let's just see whether it generates anything interesting. I think it's not going to generate anything here. Just more of the same.
Hmm.
So,
Yep. Good time to wrap it up then.
fine. Let's just initiate these additional things and humans leave. Okay.
All right. Sounds good.
Okay. See you later. Thanks. Bye.
Yeah.